Welcome back, Patriots. Let's do our test review. Only 24 problems, but there's a lot of stuff with exponent properties and composite functions, and I know that gets a lot of people frustrated. So before we go through this, I just want to remind you about some of our exponent rules. Remember when we have a let's do 2a plus 3a. Let's do that with a fifth and a fifth. Nope, that's a bad example. Let's make that a 9. Whenever we add them, we add the coefficients. So that's 11a, and then the power does not change at all. If I was to multiply those, then my coefficients are multiplied. 2 times 9 is 18. And then the exponents get added. 5 plus 5 is 10. Then, along the same route, if I had something that I was going to, let's say, cube, then whenever I have a coefficient raised to a power, we do the exact same thing we would think of. We just raise it to the power. So 2 to the third power is 8. But then on the exponent, I end up multiplying them. 5 times 3 is 15. So essentially what happens is every single time that I do something with an exponent, it moves it down 1 degree of difficulty. For example, I'm adding here, but my exponents do nothing. And the only thing that you can do simpler than adding is nothing. Whenever I am multiplying, notice that my coefficients get added. So the multiplication turns into an addition to make the 10th power there. Also, whenever I have this raised to the power here, the coefficients now get multiplied. So we go down from an exponent to a multiplication. All right, let's run through this and see what all we can do. Okay, first off, we're going to simplify each of these separately. 3 squared is 9. And then a to the first squared, there's a hidden 1 there. So we multiply 1 times 2 gives me 2. Then we're going to take that hidden 1 there. A to the first to the fourth is a to the fourth. And then b, third power times fourth power is 12th. Now we're going to multiply through. There is no coefficient to multiply a 9 with, so we just get the 9. And then a, we take our a squared and our a to fourth, add those together, we get a to the sixth, and then b to the 12th. There's nothing to multiply it by or add to it. So it's just going to be 9, a to the 6th, b to the 12th. Now for number 2, we're dealing with multiplication here. 4 times negative 2 is negative 8. And then our ends, n to the 5th times n squared, we add the exponents. 5 plus 2 is 7. Number 3. Now remember with division, we have that whole analogy of the war going on, and whichever the exponent is going to end up on whichever side has the greater numbers. So let's go ahead and simplify our coefficients first. The 2 over 7 is going to reduce like it always does or always has down to 1 over 7. Now, let's look at our x's. Again, this is x to the first power. X cubed is larger on top, so we're going to have the x on top. Then we subtract the exponents. 3 minus 1 is 2. Now, for the y's, they have the exact same coefficient. The exact same exponent, so those are just going to cancel out. Now the z's, again, the z to the fourth is larger, so z is going to end up on top, and then 4 minus 3 is 1. Now whenever I was actually writing that, I wouldn't write the 1, I would just write x squared z over 7. Okay, moving on to number 4. Let's simplify this one piece at a time. I'm going to take care of this piece first and just copy the rest of it down like it is. So I've got a squared, c cubed, 4a to the 8th b. Now, I want to go ahead and talk about, before we do that, one that I circled, this negative 7 power. Remember, the negative exponent in a fraction just means that that one is a traitor. He needs to go to the other side. So that c to the 7th is going to come up to the top. Remember, that negative means he needs to go to the other side. Now, for this b value here, we've got b to the negative 4th cubed. Well, because we have a power to a power, we multiply them. So that is b to the negative 12. Now, that in turn is going to be a negative exponent. So he is going to have to go down to the bottom side as well. So whenever I simplify this farther, that's going to be a squared c cubed c to the 7th over 4a to the 8th b, and then I'm going to bring down that b to the 12th. Okay, now let's start collecting all of our like bases. On top, I've got a squared. Now I've got a cubed and a to the 7th. Now remember, whenever I multiply these two, the exponents end up getting added, so that is c to the 10th power. And then on bottom, I got 4, a to the 8th. And then our b's, there's 1 b here and 12 b's there. That's 13 b's. And now only one more thing I've got to do. The a's are on both sides of the fraction bar. So now I've got 2 and 8. The 8 is larger, so the a will end up being on bottom. So they'll use me just as c to the 10th on top. We've got 4a. I'll come back to that exponent in a second. Now I got to subtract the 8 and the 2. 8 minus 2 is 6. So there's my simplified form. That one was a huge step up from number 3. Okay, wow. Actually, a student here live in class just pointed out I made a mistake on this. The mistake that I made was my 4th power here, and I dropped it there. So let's go ahead and finish that all the way through, or figure out where all that's going to go. That should have been a 4. Now, as I go across, this one also right here should have been a 4. Then on the next row, so this should have been b to the 4th times b to the 12th. This right here, this 13, is going to be wrong. I should have added 4 plus 12 to get 16, which then is going to make that be 16. Sorry about that, but hey, we all make mistakes. That's why we write in things that we can erase. Okay, number 5. Good news. Anything to the 0 power is 1. So this whole thing right here is just 1. So my answer is 5y squared. Done. I like simple problems like that. Remember when I first introduced the 0 power to you, I told you that math teachers love to put complicated things to the 0 power? There's an example of it. Okay, number 6. This guy being negative means he needs to go to the other side of the fraction bar. So I've got 3m, and then I've got m to the 5th. There's nothing left on top, but I got to have something there, so I'm going to put that 1 in. Now I'm going to simplify m to the 1st times m to the 5th. Add the exponents is m to the 6th. Number 7. This one, be careful with, because this is our first one that has a subtraction sign on it. And whenever we have a subtraction sign, that means I've got 2 terms on the inside of that. I've got to distribute out this 5x. So 5x times x cubed is 5x to the 4th power. Remember, that's got a first power, and I add the powers. 1 plus 3 is 4. Now 5x times negative 2y, multiply the coefficients. 5 times negative 2 is negative 10. And then we got the x and the y that you cannot combine. So we got 5x to the 4th minus 10xy. Okay, moving over to number 8. Now notice this whole thing is just one big giant addition problem. So when we add things, all we're going to do is combine like terms, and like terms happen whenever you have the same base and exponent. So here, 2x cubed and x cubed, we're going to add those together to get 3x cubed. There is only one x squared, so that's just going to be 5x squared. There is only one x, and so that one gets written down. And then we've got our -8 and our +2 are going to add together to be -6. Number 9. Now this one is a multiplication problem. And remember that when we multiply things with multiple terms, we've got to distribute. So we've got to multiply the 2 times everything and the 4 times everything. So we're going to go through and do that. 2w times 4w squared. 2 times 4 is 8. W times w squared is w cubed. Remember that understood 1 there. Now the next one, 2w times -w, is -2w squared. And then 2w times 3 is plus 6w. Now to distribute the 4. 4 times 4w squared is 8w squared. 4 times -w is -4w. 4 times 3 is 12. Oh, well, mistake there. That should be a 16. I apologize. I added instead of multiplied. Okay, now we're going to start combining like terms. There is only one 8w cubed, or w cubed. Now, for w squares, we've got our -2w squared and our 16w squared. Those are going to add together to make plus 14w squared. Now our w's, I've got 6w and -4w. Add those together and I get plus 2w. And then I've got this guy on the end, so just plus 12. Okay, number 8. With a subtraction, make sure that you distribute the subtraction mark before you do anything else. So I'm going to distribute the subtraction, and I do that by just changing all of the signs. And now we're just going to be combining like terms as we go. 2x cubed and -x cubed becomes x cubed. 5x squared, that's the only x squared term, so it gets copied down. Positive 3x squared is the only x term, so that's plus 3x. And then we've got our constants on the end. -8 plus -2 is -10. Okay, number 11. Another subtraction problem. We're going to start off by distributing the subtraction sign. Make that a plus. And then you got -6, -3x, and then positive 12. Okay, so x squareds. I got -4x squared and -6x squared makes -10x squared. The x's, I've got 2x and -3x makes a -x. And then my constants 1 and positive 12 makes plus 13. Number 12, this is another multiplication problem. So again, we're going to distribute everything. X cubed times 4x squared is 4x to the 5th power. Remember, we're multiplying the coefficients, adding the exponents. Now, times -3 is -3x to the 4th power. X cubed times 2 is plus 2x. -5x squared times 4x squared is -20x to the 4th. Now -5x squared times -3x is positive 15x cubed. And then multiply by 2, and I get -10x squared. Okay, another mistake here. that should have been x cubed on that. So I'm actually glad I'm doing this live in class because I'm actually pausing it after just about every single problem, and my students are pointing out all the places that I'm making mistakes. So now let's run through all of our number or our combining like terms. There's only one x to the fifth, so we got 4x to the fifth. Now I've got x to the fourth. I've got a -3 and a -20. Makes -23x to the fourth power. Now x cubed, I've got a 2 and a +15. Makes a +17x cubed. And there's only the one x squared term on the end, so -10x squared. All right, number 13. Solve using long division. Must show you work. I know long division is everybody's favorite thing to do. So, it could be done with synthetic division, you're right. However, this one directions specifically say long division, so we're going to do it that way for the purpose of practicing them. If you want to double check it with synthetic division, by all means, go ahead. So we're going to put in n squared minus 8n minus 26 divided by n plus 2. Remember, when you do these, always check to see if there's any missing terms. We got x squared, x to the first, and then the constant. So we are fine there. So again, we're keying off of the first terms. What do I multiply n by to get n squared? Well, I need an n. So now, n times n is n squared. N times 2 is plus 2n. Next step, we subtract off, which means change all the signs of all of them. Those two should cancel out. -8n minus 2n is -10n. And then we're going to drop down the -26. Now we're keying off of this one, the -10n. And I need to multiply n by -10 to get a -10n. Now we're going to multiply through. -10 times -n is -10n. -10 times 2 is -20. Now we're going to subtract it, so we change all of our signs. Those canceled out, and we're left with -26 plus 20 is -6. Now I've got a smaller exponent here, which is no exponents compared to the n, so that's my remainder. And the way that I write it is the quotient up here goes on top, and then the remainder goes over the original divisor. So remember, this whole thing goes there, this piece goes there, and also there's that negative sign, and then also this piece goes there. Okay, number 14. I need to check. I've got cubed, squared, 1, none. So I'm good on all my terms being present. So I've got 6x cubed minus 31x squared minus 34x plus 22 divided by 2x minus 1. Now this one, on the other hand, cannot be done by synthetic division. The reason it cannot be done with synthetic division is because of this 2 coefficient. Okay, how many times does 2x go into 6x cubed? Well, I need a 3, so 2 times 3 is 6, and then I also need an x squared. Now let's multiply through. 3x squared times 2x is 6x cubed. X squared times -1 is -x squared. Now we're going to subtract, so change all of our signs. Oh, I did forget my 3. Hold on. 3x squared times -1 is -3x squared. Okay, those are going to cancel out. Now we've got -31x squared plus 3x squared is -28x squared. We're now going to drop the -34x. Okay, now we're keying off of the negative 28x squared. 2 times negative 14. What am I doing? Negative 14. And then I need another x to make an x squared. Negative 14x times 2x is negative 28x squared. And then negative 14x times negative 1 is positive 14x. Now we're going to change our signs to do the subtraction. Those cancel out. Negative 34 minus 14 is negative 48x. And then we're going to drop down the 22. Now we're keying off of the negative 48x squared. 2x and negative 48. Well, I've got the x already. I just need a negative 24. Because 48 divided by 2 is negative 24. Now let's multiply through. Negative 24 times 2x is negative 48x. Negative 24 times 1 is positive 24. Now let's subtract that out. These cancel, and I'm left with a negative 2, which ends up being my remainder. So I write my answer as 3x squared minus 14x minus 24 minus 2 over 2x minus 1. Number 15. Hey, there's two number 15s on here. Okay. That's also interesting. There's a typo here. There's supposed to be a division mod on those. That's supposed to be a 16. And there's also supposed to be a division sign on those. Okay, let's look for any missing terms, and I don't have any. So x cubed minus x squared plus x plus 3 divided by x squared minus 2x plus 3. Okay, we're keying off of the x and the x squared. I need another x. Now let's multiply through. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times 3 is 3x. Subtract, so change all of our signs. Now these two canceled out. Negative x squared plus 2x squared is positive x squared. X minus 3x is minus 2x, and then we're going to drop down the plus 3. Okay, now we're keying off of the x squared. Now, I already have an x squared. I need an x squared. X squared goes into x squared 1 times, which is plus 1. I like multiplying by 1 because it's so easy to do. X squared minus 2x plus 3. Subtract all those off, and I get 0. So that one evenly divides in. My answer is just x plus 1. Okay, let's move on to the second number 15, which should be 16 if it was labeled properly. Let's see if we have any missing terms. No, we don't. 6x cubed plus 7x squared minus, I'm going to scoot this down so I have more room to write. 7x squared, 6x cubed, minus 18x plus 15. And then 2x squared plus 3x minus 5. Okay, looking at the 6x cubed and the 2x squared. 6 divided by 2 is 3. X cubed divided by x squared is x. Multiply through. 3x times 2x squared is 6x cubed. 3x times 3x is plus 9x squared. 3x times negative 5 is negative 15x. Change the signs for the subtraction. Those go away. Scoot that bar up a little bit. Now 7x squared minus 9x squared is negative 2x squared. Negative 18 minus 15 is negative 33x. And then we're going to drop down the 15 for our next row. Next up, we're doing our keying off of the negative 2x squared. But before I do that, I want to go ahead and fix this. Negative 18 plus 15, not minus 15, plus 15 is negative 3. Okay. Now, we got 2x squared. We need negative 2x squared. That'll just be a minus 1. Negative 1 times 2x is negative 2x squared. Negative 1 times 3x is negative 3x. Negative 1 times negative 5 is positive 5, which I like those numbers because when I subtract them out, those cancel out, and it leaves me with just a 10 on bottom. So my answer here is 3x minus 1 plus 10 over 2x squared plus 3x minus 5. Moving on to number 17. Solve using the synthetic division, which I love so much more. Now remember, synthetic division only works when you have a coefficient, a leading coefficient of 1 and an exponent of 1. So something just like this, x plus 2. Now remember our process here. We're going to write down our coefficients and make sure you look for any missing spots. For example, I'm missing here this x squared, so I got to put the 0 in for the x squared. So we're going to do 3, the 0 for the x squared, negative 2, and 5. Over here inside of the bracket, I'm going to change the sign of this one and make this a positive 2. Now remember the rules. You're going to multiply down and then add up. Okay. So, no. I said that wrong. Multiply up, add down. Okay. So the 3 gets carried down. Multiply up. 2 times 3 is 6. Add down. 0 plus 6 is 6. Multiply up. 2 times 6 is 12. Add down gives me positive 10. Multiply up gives me 20. Add down is 25. Now remember, we're going to take our original, the original exponent and decrease it by 1. So this is 3x squared plus 6x plus 10, and then this is our remainder on the n, so x minus 2. For number 18, I'm looking at that and I see x to the 4th cubed squared, 1, 0. Everything is all accounted for, and I'm set up properly with this divisor. So we got x plus 2. So I'm going to go ahead and set this up, change the sign to negative 2, write my coefficients down, 1, 5, 2, negative 6, and 4. Add down, bring the 1 down, multiply up. 1 times negative 2 is negative 2. Add down gives me 3. Multiply up gives me negative 6. Add down gives me negative 4. Multiply up gives me positive 8. Add down gives me 2. Multiply up gives me negative 4. Add down gives me 0, which means I've got a 0 remainder, and I like that. I had x to the 4th, so I'm going to make this x cubed plus 3x squared plus 4x, or minus 4x plus 2. And I don't have to worry about that remainder. Number 19. Again, I'm looking for anything that's missing. X cubed, x squared, x to the 1st. Okay, no, I'm good. So I'm going to set up, change the negative 1 to a positive 1. 3, 5, 2, negative 10. Add down gives me 3. Multiply up is 3. Add down is 8. Multiply up gives me 8. Add down is 10. Multiply up is 10. Add down is 0. Again, remainder 0 is good. I originally had an x cubed. Decrease that by 1 makes x squared plus 8x plus 10. 3x squared plus 8x plus 10. Oh man, these synthetic divisions are so much faster. Number 20. X to the fourth minus 2x squared minus 1. Now, I do see that I'm missing a x cubed term as well as a x term. So I got to make sure I put those in. Change the sign to a positive 3. 4x squared, 0x cubed, negative 2x squared, 0x minus 1. Okay. Add down gives me 4. Multiply up gives me 12. Add down gives me 12. Oh, wow. Yep. I put a coefficient there instead of an exponent. Or that should be a 1. Let's finish this or fix this. Okay. Add down gives me 1. Sorry about that. 3 times 1 is 3. Add down gives me 3. 3 times 3 is 9. Negative 2 plus 9 is 7. 3 times 7 is 21. 0 plus 21 is 21. Times 3 is 63. Add down gives me 62. So I'm going to decrease that by 1 to get an x to the third plus 3x squared plus 7x plus 21 plus 62 over x minus 3. Last section. Now we're going to do all of our composition of functions. So we want to find f of g, g of h of x and h of g of x. Now I'm going to do these kind of on this here in the middle and then write the answers on the side. So when we do g of h of x, remember we start with g, and so we put 4x minus 5. We replace the x with parentheses. Now inside of it, we're going to plug in the 2x plus 1. We're going to plug in h. So 2x plus 1. Now we're going to distribute, which is going to give me 8x plus 4 minus 5. And that will simplify down to 8x minus 1. For h of g of x, we start with h this time. Now it's 2x plus 1. And now we're going to substitute in the 4x minus 5. Distribute the 2x, and that gives me 8x minus 10 plus 1. So when I simplify that, I'm going to get 8x minus 9. All right, number 22. Exact same idea. Going to be a little bit more complex because I have a squared in this one. But whenever I do g of h of x, I'm going to start off with x squared plus 4. I'm going to place h on the inside of that, so negative 2x plus 1. Now we got to remember what squared means. Squared means multiply something by itself. So we're going to write out that one twice. And now we're going to multiply this thing out. Negative 2 times negative 2 is negative 4x squared. Negative 2 times 1 is negative 2x. 1 times negative 2x is negative 2x. 1 times 1 is 1. And then that plus 4 drops down. So when I combine all my like terms, I've got negative 4x squared. Negative 2 and negative 2 make minus 4x. And then 1 and 4 make 5. Now for h of g of x, this one's not going to be as complex. We start with h. We do negative 2. x plus 1. We're going to plug in g, which is x squared plus 4. And now we're going to distribute out that negative 2, which gives me negative 2x squared minus 8 plus 1. Now we combine our like terms. Negative 2x squared minus 7. Number 23. Okay, we want to find f of g of negative 4 and g of f of negative 4. So we're going to start off by doing f of g of negative 4. So start with the outer function f, so x minus 7, giving myself plenty of room in order to fit that in. Now g is x squared, so I'm going to put my x squared plus 1. And then I'm going to plug in the negative 4 into that. So as we start unraveling this whole thing, negative 4 squared is 16 plus 1. Now, that gives me 16 plus 1 is 17, and then 17 minus 7 is 10. Now to do g of f of x, we're going to start with g of f of negative 4. Start with g, which is x squared plus 1. We're going to plug in f, which is x minus 7. And then we're going to plug in the negative 4 into that. So, as we simplify down, negative 4 minus 7 is negative 11. And then negative 11 squared is 121 plus 1 gives me 122. Last problem. We want f of g of 3 and g of f of 3. So f of g of 3, start with f, is for x. G is 5x minus 1. And then we're going to plug in the 3. So let's start simplifying down. 5 times 3 is 15, minus 1 is 14. And then 4 times 14 is, oh lordy, 14 times 4, 6, 1, 56. Now we've got g of f of 3. So start with g, 5x minus 1. Plug in f, which gives me 4x, and then plug in a 3. Let's start simplifying down. 4 times 3 is 12. Now, 5 times 12 is 60, minus 1 gives me 59. So, that's all of it. I'll be on Google Meet every single morning this week. Actually, all the rest of the semester, every single school morning, 8 a.m. to 8:35 to 8:40. EVHS Mr. Love is the code. Let me know if you have any questions or need any help on this.